So all the given information in this problem can just be pulled directly off of the graph by counting. So it's important that you verify when it says that there's a horizontal component of 5 units. If you count horizontally, that first vector should have a horizontal component of 5 and a vertical of 3. And then that other vector that's going straight up should be going straight up with a length or magnitude of 4 units. So what's happening is these two vectors are colliding and then causing a new vector. So basically you can picture this arrow coming straight up, running into this arrow, and then pushing it up here, making a bigger angle and making the magnitude larger as well. So the idea with problems like this is that when a vector gets hit vertically, its horizontal component doesn't change. You can see that this vector and this vector both have the same horizontal component. And then what happens with the vertical component is this was the vertical component initially, but then this new vector comes in and adds to the vertical component, making it bigger, right? And we can just directly add both of those components. So what we say first is that our horizontal component is going to be the same. So that's just going to be, in here, let me draw this arrow over here now, this new vector, right? Okay, horizontally it's still going to be 5. And then vertically, it was 3, but we've added 4, so now it's going to be a total of 7, right? That's 3 plus 4. So then if we want to find the new magnitude, we have to do the Pythagorean theorem on this. So we're just going to do the square root of 5 squared plus 7 squared, which is going to give us about 8.6 meters per second. So that goes right there. And then next, what we want to do is find this angle. So we have our angle, we have our opposite side, we have our adjacent side. We actually have our hypotenuse too, if you would rather use like arcsine or arccos. But I would like to use arctan of 7 over 5, and that's going to give us 35.54 degrees. But then what you see is that this angle is this angle, right? It's this angle. And that's not the angle we want because this is asking about bearing. So if you think of this as being north, east, south, west, we want to figure out how far west of south or west of north we are, right? So if this angle is 35.54, then that must mean that this angle we want, which I'll put in blue, is going to be 90 minus 35.54, which is 54.46 degrees. So our final answer then is going to be that this is moving at a bearing north 54.6 west at 8.6. And I don't know why I did meters. It should really just be units per second. We never really specified what the units represented. It could be feet, it could be meters, it could be miles. But yeah, so that is our new resultant vector. A box this answer.